Okay, everybody, we're going to do a really quick intro to pressure. Make sure you have your formula sheet out because you need to add this to it. So what is pressure? It's the continuous force exerted on or against an object by something it's in contact with. That's the basic definition of pressure. Mathematically, pressure is equal to the force exerted on the surface divided by the total area which it's extended, or exerted, which is basically saying pressure is force divided by area. And down here I have the three different ways. Pressure is force divided by area. If I solve for force, it's pressure times area, and area is force divided by pressure. If you've seen me in class before, you know that we use the triangle quite a bit. And the triangle is you basically take the ones that are multiplied together and those go on the bottom, because when items are next to each other, you multiply them. If things are on top of each other, it's division mathematically. So if I were to say find pressure, I would cover up the pressure on the bottom left and it would be force divided by area. If I wanted to find area, it is force divided by pressure. And if I wanted to find force, by the way, here's another way in which we can find force. Force is pressure times area. And this Pascal is the unit that we're going to use for pressure. And if we do that, it's a Newton divided by a square meter. So 1 Newton divided by 1 square meter is equal to 1 Pascal. That's the definition of pressure mathematically for what we're going to be using. So that's also important. If we give you something mathematically and it's not in square meters, you need to convert to square meters. It also needs to be in a Newton. The other thing I need you to be aware of is, even if you've come from another instructor, you need to have your formula sheet because it doesn't go away. We build, and this is the unit where we're going to be using almost every single formula to do some problems. In fact, by the end of this unit, you will have done 3 or 4 different mathematical equations to solve for pressure or the final question. So you need to be keeping track of your units. So minimum you're going to need to know is pressure, area, density, speed. Remember, speed in a given direction is known as velocity. Gravitational acceleration on Earth because it's dependent on the size, the mass of our planet, is 9.8 meters per second squared. So our weight on Earth, anytime you're looking for weight, it's the mass in kilograms times 9.8 meters per second squared. And that unit, again, because it's a force unit in the metric system, weight is in a Newton. The original formula for acceleration is final velocity minus initial velocity divided by time. Here's our force. Here's momentum. These are formulas you need to make sure you have ready for you on the test, or you need to be using one of my formula sheets. So I want to talk just a little quickly about pressure. If you have a snowshoe versus a sneaker versus a stiletto, and you try and walk in snow, it's going to be a totally different experience. If you have ever seen someone wear a stiletto heel, all of their weight goes down through the center of their body, through their heel, and all of that weight is actually transferred through the heel down to that little tiny point on the stiletto. That is a lot of pressure on a very small area. And pressure, while it involves force, and I can have the same mass, I can have the same gravitational amount of newtons pulling me down, but if I change my shoes, I can walk on snow or sink in it. So if I wear stilettos, I'm probably going to sink through the snow. If I wear sneakers, I might not go all the way down into the snow because now my pressure is spread over a larger area versus a stiletto. But if I really want to walk on top of snow, I need to spread my force over a really large area, in which case a snowshoe is the better choice. So sink, all the force in a teeny tiny area you're going to puncture through, versus sneakers spreading over a bigger area, which is why it's easier on your feet than stilettos. And believe me, I know, because I grew up in the 80s and I wore high heels every single day in high school and college. I don't anymore. But snowshoes are what you want to do if you want to walk on 12 feet of snow and not fall all the way through and not be able to get out. What's interesting is if we look at this stiletto versus an elephant's foot is over such a big area, it's going to have lower pressure on a given area than the stiletto. And what's really interesting is if you take a look at this cross section, this is a cross section of a foot in a heel, and this is the cross section of an elephant's foot. Nature is really good at recycling and reusing ideas. And what the elephant does, it actually walks on the front of its foot, and there's this whole padding there so that there's a cushion on the impact and spreads the elephant's mass over a much bigger area. Now, you might not think this is a big deal, but pressure is a big deal. No pun intended. Pressure is what we deal with all the time. Even if you've ever watered the garden, you have a hose. You have water coming out of it. If you put your thumb over the top of it, you're changing the pressure. You're backing up the water inside there. You're making it come through a smaller area. And the force comes out, it can shoot farther and you can hit the back of the garden without ever having to move. So this is a really quick intro to pressure. We are going to spend a lot more time on this. I just need you to make sure that you are paying attention to the formula sheet, that you've added this on and you're ready to go, because in 2 days we're going to be doing a whole lot of pressure problems.